So if I walked up beside you today and I stuck my head inside your ear, through your eardrum, beneath some bones, I would find this beautiful structure called a cochlea. It's pretty cool, right? But it doesn't stop there, because if I looked even deeper inside your ear, I would see that the cochlea is like a sanctuary for these neat rows of cells, each with tiny, delicate hairs. And these hair cells are so sensitive that they can detect the slightest vibrations, and then they pass them on through nerves to the brain. You can think of them like little microphones passing information through a cable, this doesn't have one, to a computer. And once this information reaches the brain, it's heard as sound. The patter of rain, nails down a blackboard, or the Melbourne Symphony Orchestra playing the soundtrack to Toy Story. But these nerve cells and the hair cells that they innervate are under threat. You might know someone in your workplace, your family, your friend group that has sensory neural hearing loss. That means their sensory, their hair cells, and their neural nerve cells are dying, and they're losing connection with each other. Our laboratory is developing a treatment. It's a drug-loaded nanoparticle that can tell these cells to regrow and reconnect. But there are so many different ways to make nanoparticles, and we need a way to test them all on a level playing field so that we can find out the best one to give to patients. So my project was to create a cochlea with hearing loss so that we can test our nanoparticles and figure out the best one to progress onto clinical trials. So we did this using cochlea explants. That means we take a cochlea out of a mouse, stick it in a dish, unwind it, and then treat it with a toxin to mimic hearing loss. And this toxin is what hair cells normally release when they detect sound. So you can imagine if we overload the cochlea with this molecule, it's like we're subjecting it to a lifetime of death metal music without even making a sound. And I'm excited to share that these cochlea explants look exactly like they have hearing loss. Hair cells die, and our preliminary data shows that they lose connection with their nerves. So this is a good thing. It means that the most exciting part of this research is just around the corner. Soon, we'll see if nanoparticles can encourage hair cells to reconnect with their nerves, stop them from dying, and ultimately restore beauty to the cochlea. Thank you. And I'd just like to thank the Hearing Therapeutics team at the Bionics Institute. This placement has been really transformative for me, so thank you to everyone that's made it so special. And with that, I'll hand over to the next presenter. Thanks, Isla.